For example number 1, we're now going to use the second derivative test, and that's going to help us analyze the critical points a little bit more quickly. So let's go ahead and start out with the function that they give us. They say let's work with f of x is equal to x to the third minus 6x squared plus 10. So f prime of x, the first derivative, is 3x squared minus 12x. Okay. And so that, let's get our critical points. That is going to be 3x times x minus 4, like that. And so now we'll set that guy equal to 0. Use the zero product property here, and that implies that our critical points are at x equals 0 and x equals 4. Now let's take a look at f double prime, or the second derivative. Well, that is 6x minus 12. And that guy, we're going to take a look at it, okay, at these two values and see what happens. So, at x equals 0, we have the following. We have f prime of 0 is 0, and f double prime at 0 is negative 12. We took this and plugged it into here. Well, that tells us the following. So if I go ahead and I sketch out the graph, it tells us that at 0, I don't know where my function is. Well, I do know where it is for its height. It's up at 10. Okay, so here, let's label this point. At 0, 10. Okay. First, I know that this guy's a critical point. The second thing I know is that the second derivative is negative, which means the first derivative is decreasing, which means that the first derivative is going down, or it's the rate of change of the slope is decreasing. And so if that's the case, it doesn't say the slope can't be positive or negative. What it's just saying is that the slope is getting more and more negative. Okay, so what we know is that we must have a hill, because think about it. Here's the tangent line, here's the tangent line, here's the tangent line. The first guy, doesn't matter whether it's positive or not, okay, but notice that it's here, now it's here, now it's here, now it's here, now it's here, and they're getting more negative. Okay, so these tangent lines are getting more and more negative. They're decreasing. Okay, so it means we're at a hill. So I always like to think about it in reverse. If you have a negative second derivative, you're at a maximum. If you have a positive second derivative, then you're at a minimum. And if you have a second derivative that's 0, then the test is inconclusive. We can't tell. Okay, so now let's go ahead and take a look at this guy. Well, we know, so at x equals positive 4, we know f prime at 4 is equal to 0. Okay, that's when we plug it into here. We also know at 4, let's just do the calculation here so we can tell how high we're at. We know at 4, we are 4 raised to the third, okay, minus 6 times 16 plus 10. So it's negative. We're down here at negative 22. When we're out here at a length of 4. So there's our point. Okay. We also know that f double prime at 4, the second derivative at 4 is going to be positive. It's 24 minus 12, or positive 12. So that means, since it's positive, that means the slopes are increasing. So the slopes have got to be coming through like this. So we're at a minimum. So this guy right here is a local max. This guy is a local minimum.